This show is a part 2 to some shows that I have done on infrastructure as code, creating resources in Azure, and showing how to get them connected to a key vault and a storage account with various infrastructure as code technologies, so Bicep, Pulumi, and Terraform. In this show, we're going to create the API that will run in the app service. That's this guy here. And then we need to make sure that that runs in Azure and can successfully connect to the Key Vault and the storage account. Equally, we want to make sure that it can run locally and still connect to both of those resources. All right, so let's jump in. Create an ASP.NET Core web API. I'm just going to fly through this and probably speed up the show whilst I create the API. Okay, that's the first API. I'm going to create two because I want to show some subtle differences between when you're running it in Docker, running it in a container, versus running it as code. Okay, I have created those two projects. We've got a code-based test API and a container-based test API. We'll go and create the code in the code one first. And I've gone ahead and added those to the repository under SRC folder and pushed that so you can, if you're curious, you can have a look at the code and the changes that we apply as we work through creating this. The first thing I want to do is just get rid of this redundant stuff. Get rid of all of that. Okay. Now I want to add a test function that's going to run off and test connection to the storage account and Key Vault. Now, like I did in the shows where we generated the infrastructure as code, we're going to lean on ChatGPT and get the sample code generated for us, at least the starting of it. So I have this in my .NET 8 web API. I want to do this connectivity to a key service and a storage account in that function. Right, so this right here is a good example of why I like to use ChatGPT to give me the starting point. It's not only has it given us some code to test the connectivity, but it's also told us what packages we need, which is really useful. Now you can just simply copy that and run it in your developer PowerShell or in your actual PowerShell. I want to add this to both projects, so I'm just going to manage NuGet packages for the solution, and then look for Azure Identity, and basically add those three packages from here. So I'll do that now. All right, they're installed. So now let's grab the code that has been generated for us and see what that looks like. Drop it into our program here. Don't need that so much anymore. Okay. Personally, I like having vars, so I'm just going to quickly go right click and where is it? Clean up code, which comes from it's a quick little thing from ReSharper, and run it, and it just makes some. It's not just the vars; it does other little improvements, but nice little helper. Right, so out of the box, looks like the only thing we're going to need to change is these URLs. Possibly the name of this secret, and then we should just be able to test and see if it works. So to get the Key Vault URL, where do you find that? Go to your Key Vault, and there it is right there on the overview, the Vault URI. Grab that and replace this. And for the storage account, it's not on the overview because there's a few different things that are a part of the storage account. So you've got to go down to endpoints, and we're going to be hitting the blob service. So this here is the URL that you want for that guy. So we'll drop that there, and so my secret, let's just leave that for the moment and just run it and see if it works. And we haven't set up anything locally to give us permission to connect to these resources that are running in Azure. All right, and here we've got an error. What's the problem? A secret with that name was not found in the Key Vault, which suggests that it actually connected. So given we haven't set up any connection details, why has it done that? Right, well, let's dig in a bit deeper and we'll find out why. Now we're using the default Azure credential here when we create our client to try to connect to the Key Vault, and also when we try to connect to the storage account. So let's just Google that and come into default Azure Credential class, the documentation, and here it tells you, so it attempts to authenticate with each of these credentials in the following order, stopping when one provides a token. So there's quite a few things where it's going to try, including your Visual Studio, if you've got access to the Azure resource based on how you're logged into Visual Studio or Visual Studio Code, but also you'll get access potentially from your Azure CLI login. So if we do AZ account show, you can see that I am logged in and have access through there. So that's a good way to set up developer access when running locally to the Azure resources. So my user currently has access. How does it have access? Well, it's my own personal Azure account, and so I've got access to everything. But in a more enterprise scenario, you're going to have much more restricted access, and not every developer is going to be able to access everything. I would recommend that you definitely provide access through the user. That would be the better approach. And whether it's the user that they're logged into Visual Studio with, or if you make them log in through the Azure CLI, that sort of doesn't matter. From the developer's perspective, their user has access to the relevant resources. From an Azure perspective, their user is a member of a group, and then that group should be granted access to the relevant resources. So I've got this developers Azure IaC group here, which I would add myself to, and then in the Key Vault, I would grant the necessary access in the role assignments. Say, for example, we'll add a reader role and then just managed identities and, sorry, not managed identities, group. Close that. Group, select members, and as developers IaC, review and assign. And now that group has the reader access. You should also add, and I have previously added the Key Vault secrets officer, which will allow them to look at individual secrets. Otherwise, when you come here, it'll say you don't have access to any, you aren't authorized to view secrets. Okay, and there's one other way you can access if neither of those are an option for some reason. Well, there's probably more, but another way that I'm familiar with is you can set environment variables. So like this, and these are the environment variables you need to set. What are they and where do you get them from? So come into Entra ID, and it's an app registration. Create a new registration called Azure IaC App Reg Test. And I'm just going to register that, get a secret. So it has an object ID here, so we're going to need that. And the secret, new client secret, and test secret. That'll do. We'll just expire it. I'm going to delete this fairly quickly. So that's the secret here. Copy it. The very first thing you should do is put it into 1Password or KeePass, some sort of secret management tool. Always make a habit of always saving those somewhere so you can access them again. Now I always get confused. Should I use the application ID or the object ID? Let's go with the application or client ID, since that's pretty much what this is asking for. Now keep in mind, I've done the wrong thing here. Oops. I'll need to add this separately, and the place that we add that is in environment variables. So you would come into your environment variables and add a new one, and that should be called Azure Client ID, and drop that there. And another new one, Azure. And the tenant ID is right here, so we'll copy that from there as well. So it's just on the system. Okay, so we don't need that. And now when we run it, those values should be picked up. We'll just test that they are coming through or recognized by the program. Okay, they are not. So, all right, why? All right, I've got those values coming through now. Just had to do a restart of Visual Studio, so it would pick up the new environment variables. Now, just referring back to the documentation again for the default Azure credential. Let's just quickly go back to that, which I've closed. If you recall, the first thing it's going to do is, this is the order that it goes in. So the first thing it's going to do is the environment credential. Visual Studio is down the track. The environment credential is this Microsoft Entra ID, client ID, and secret. So, and these are the values that we just added to, sorry, the environment variables that we've just added. So it's actually used first. So that's what should get used if we continue through. Okay, so the caller is not authorized to perform this action. So secrets get secret action. So if we come back to our key vault, let's just get out of there into the key vault. Why couldn't it get the secret? Well, it couldn't get the secret because we've only given it no roles at all. Okay, so well, let's give it some permissions. That would be helpful. So let's give it reader for our service principal. So we come in service principal, and we're going to have to give it the right name. So it's called Azure IaC App Reg Test. So we'll do that, select that, and review and assign. All right, let's just test that. I think it needs another role, and just continue through. And action, get secret action. Did not work. So stop that again. And we're going to give our service principal, this time we'll give it a secret officer. Key Vault secrets officer. And select member, Azure IaC. Do that and assign. And then we'll run and see if it works. Sometimes it can take a little while to propagate. In this case, didn't take any time. So this time the error we're getting is a secret with my secret was not found. That's because the secret that we have created is called test secret. So let's change that. Run it again. I might just remove it. All right. And so we've now got our secret value, which is my test value, which we can see in the key vault. Show the secret value is my test value. So the key vault works. What if we race through and test now it's on the storage account and it doesn't have permission. That's expected because we haven't given it permission yet. So let's go into the access control and add a role assignment, and we want blob contributor so that we can write and read. Then we'll select. So service principals don't come up in here by default. There's our service principal. Review and assign. This time when we run it, we should see a different result. All right, so connectivity to the key vault and the storage account is successful. The next thing we need to do is just confirm that when this API is running in Azure, that it is actually getting access to those two resources, the storage account and key vault, from the UAMI, the user assigned managed identity. So if we have a look at the app service, it currently doesn't have the code deployed there, but the identity user assigned, we've got access to the storage account and access to the key vault. So let's get it deployed and then confirm that it works. Okay, I'm not going to go into too much detail with the deployment process in this show, but one thing that's important to note is this operating system type for the web app we're deploying to is currently Windows. We'll change that in the future and I'll explain why in a minute. But we just right click over here, publish. I'm going to publish to Azure. I'm going to pick the Windows flavor, and that is our service here. Okay, that completed. Only took a couple of minutes. Let's just see if we can get anything there. Nope, nothing found. And I think it was test/test. Okay, nothing working at the moment. Let's find out why. So the first thing to note is on the test URL that we're getting a 500. So there's an error occurring, but we can't really see what error it is. And the other problem is the swagger's not there, saying it's giving us a 404 not found. So coming into our code, this is the boilerplate code where it will only give us the swagger if it's development mode. I typically comment this out because I often want the swagger in production. That's entirely up to your service, whether it's good for you to publish that in a production environment. And in terms of the error, let's just simply wrap all of our code in a catch. We'll just do that, exception, and this time we'll return results with a problem and some problem details. With the detail being, and we'll do the message of the exception. Okay, now let's build and publish that. And once it's complete, we should see, if we go to the test URL, now we have an error that we can actually determine more information about what's going on. So it's unable to load the proper managed identity. Okay, so we Google that, unable to use load the proper managed identity. Probably, without going through that, but that's a good place to start. Just Google the error and see where you come up, what it comes up with. Can also throw it at ChatGPT. The other thing I wanted to check here was the swagger, and that now works as expected. So the service is deployed, the service is working, it just has an error. Now, I think the reason why it's not working is because we have two user-assigned managed identities here, and it doesn't know which one to use. So let's tell it which ones and see if that helps solve the problem. All right, so let's just get rid of this bit of code here because that was just purely to test that we got the values locally. Now, this credential we're going to change to the key vault credential. And make that the key vault credential. And for the default Azure credential, you can give it some options. So we're just going to go, whoops, if I can type properly, new default Azure credential options. And below all of those excludes, we can tell it the managed identity resource ID, tenant ID, managed identity client ID is the one that we want. I'm fairly sure. Okay, so looking at our identities, this is the key vault one, and that is the client ID. So let's grab that, throw that into here, and then we've got another credential required for storage. We'll make that the storage account credential. Storage account credential, and its client ID Again, we'll just go to user assigned, this time into the storage UAMI, and its client ID is here. Copy, paste, and let's deploy that now and see if we get a better result. All right, so that's it there. Just get rid of that. Test. Okay. Connectivity to Key Vault and storage account is successful. All I did then was refresh. And obviously the Swagger should still work. So if you have multiple identities noted as identities, as user assigned identities, you need to tell in your code, you need to specify which one to use and when. All right. I mentioned before that the operating system is currently set to Windows and that we need to change it to Linux, and that I'd explain why. Basically, it comes down to cost. If you look at scale up, that will show you the costs of different instance sizes. So the basic B1, if we wanted to scale up to that, and you need to do that if you want to run it at 64-bit mode, the free version, the free instance size will only allow you to do 32-bit sys applications. Run it as 32-bit, I should say. Okay, so but the B1 is $68 a month, USD, but for a Linux version, this is my Linux sample, it's only $14 a month. And if you start to hit a production level version, the cheapest one here is $125 a month. But over here, that P0v3, same thing, is 67. So it's quite a significant difference. And because it's .NET 8, it will absolutely run in either. And which one's faster? Certainly at startup, Linux systems are faster. You'd have to do your own benchmarking to see if one outperforms the other. But yeah, for me, that's a very solid reason to, especially if you're just as a startup or this is some playing around in Azure that you're doing for your personal development, you want to keep your costs at an absolute minimum. One final thing to check is, well, what if we're running in a container? So we're going to set that as our startup project. And this is the code that's in the code project, and we can run the exact same thing. So I'm just going to simply cut and paste it. In this case, we can run the exact same code because it doesn't matter if we're running the container. Run it and see if that works. And the Swagger is there. And if we try to run the test, we get a 500 and failed to retrieve a token. So one question is, well, why did it fail? Because basically we're looking for these environment variables, and I think you'll find that, oops, yeah, that's right. I think you'll find that they're empty. And the reason why they're empty is because it's running in the Docker container, and the Docker container doesn't have access to your system environment variables. So tenant ID, client ID, and secret, all null. So where do we set those? Well, just very quickly, we can do that. And to set an environment variable, you can do that on your Docker container. So I'm not going to sit there and type that out. I'm just going to copy and paste it. This is something I prepared earlier. So working directory. Add those there. And let's try it again and see if we have a bit more success. All right, so this time it worked, but it's failed to find the identifier. So it's probably because I'm using a different one. Let me just fix that. So I've now fixed the client ID and client secret. I was just using some old ones. So again, let's see if that resolves the issue. $200 connectivity is now successful. So pretty easy to add on your environment variables into Docker as well. But just to come back to best practice, this is kind of why it's one reason why it's not a good idea to use that approach, because then you've got to manage these secrets and client ID, regularly cycling them out. If someone leaves, you've got to change it. And the developers need access to it, and some developers are better at keeping secrets and maintaining their secrets than others. And also, if everyone's using the same client ID, you don't know who it is that's accessing stuff, as opposed to giving the developers login the appropriate access. So this is how you resolve this approach, but not necessarily the recommended approach to use. So we've now seen how we can confirm that connectivity to a Key Vault or a storage account or potentially other Azure resources can be tested in a running .NET 8 API. It could be any kind of service. Fairly easy to get going. A few things to consider, such as making sure you specify the client ID for the default credential. If you have more than one, user-assigned managed identity. So I hope that's been helpful, and take a look at the infrastructure as code shows as well, that can help to set up all the infrastructure in Azure, and leave any comments you have in the show notes, comments, questions. The source code's available in GitHub. There's a link in the show notes. Yeah, so, and if that's been helpful, please do the like and subscribe thing. Thanks for watching.